So here's a little bit on the comparison of ethane and butane structures. So if you look at ethane, it has 2 carbons, whereas butane has 4, and these are ending in ane because they're all single bonds. So this is the structure kind of 3-dimensionally, showing the one sticking out the back, showing the one coming out at you. That's what those diagrams mean. And then the bond angle of 109.5, and you still have the same bond angle down here. You're just taking multiples of these and grouping them together. So you can see by like this hydrogen right here is representing this one that's sticking out the back. This one right here is coming out in front. It's coming out in front of you. So this is showing 3-dimensionally what's going on in a 2-dimensional world. So isomers, many carbon compounds exist in the form of isomers. They're compounds with the same molecular formula but different structures. So they're combined in different ways. An isomer example for this one down here is both have the formula of C4H10 but have different structures. So I have butane where it's all in a chain, and here this would be something that's branched, where one of the carbons is branching off the other one. Well, we call this, it's kind of confusing, methyl propane because there's a methyl group coming off of a propane. Propane would be the prefix used for 3 carbons in a long chain, and then we have a methyl group coming off of it. I'm not going to expect you to know how to name these, but all of these are going to have the same, these 5 alkanes have the same molecular formula of C6H14, but they have all these different names and all these different formulas, the different ways that the carbons can be combined together. And when you combine them in different ways, the key thing I want you to notice is it does change their properties. It changes the boiling point and it changes the melting point because it changes those angles. It changes the bond angles between them, and it makes some of them easier to break and some of them harder to break. So physical properties of hydrocarbons, they are nonpolar. They are not water soluble, so they are soluble in nonpolar organic solvents. They have a very low melting point, low boiling points. Generally less dense, so they're lighter than water, which is why they'll float on water, like we see oils and stuff floating on top of water. As length increases, melting and boiling points increase, as does the density. So the longer it is, the more energy you have to give it to get it to melt or to boil, which would make sense because there's more bonds to stress in there. So alkane reactions, some of the reactions we tend to think of these are hydrocarbons. These are gases. They're going to burn. The majority of the reactions of alkanes are combustion reactions. So we can have complete combustion where we produce carbon dioxide and water. You can have incomplete combustion where you produce carbon dioxide and water, or carbon monoxide and water. And of course, you know, obviously carbon monoxide is poisonous. It binds to the oxygen spots on your red blood cells and it prevents you from taking in oxygen and you will suffocate. So the functional groups are the things that bond to these hydrocarbons. Most organic compounds involve substituents. That's what we call the functional groups. These are groups that are attached to the hydrogen or to those hydrocarbons because the hydrocarbons don't react. The basic hydrocarbon is inert. So then it becomes the functional groups that are actually doing the reactions. The functional groups are things like oxygens and oxygen and hydrogen groupings or nitrogen added to them. So they are chemically active and they're the functioning part of the hydrocarbon. So it's not the hydrocarbon that's going to be doing any of the reactions. It's going to be the functional group. So we are going to fill this table out in your notes together as a class. So we're going to talk about halocarbons, which means salt. Halo means salt. Alcohols, ethers, aldehydes, ketones, carboxylic acids, and esters. So we are going to fill this out together as a class.